So, what's our backup plan if we fail to align AGI? I mean, really fail? This one question has kicked off one of the most intense, high stakes debates in the entire AI safety community. And the proposed answer? Well, it's about as wild as it gets: genetically engineering smarter humans. And get this, that quote is from Eliezer Yudkowsky. He's talking about creating cognitively enhanced humans, superbabies, as a last-ditch effort to solve X risk. When a figure like that calls this one of the most important projects in the world, you know the stakes are absolutely astronomical. And this idea has just exploded on LessWrong. The central question is this a brilliant hedge against AGI, our only real shot at creating minds smart enough to actually solve alignment? Or is it a catastrophic mistake that could unleash an even worse kind of existential risk? Let's dive into the arguments. All right, so what exactly is the proposal here? It all starts from a pretty grim premise. What if our main plan to align AI just fails? A war could wipe out the chip fabs, or maybe the problem is just fundamentally too hard for our current brains to crack. What do we do then? Well, this is the backup plan. The core idea is that genetic research is actually more resilient than AI hardware. It's decentralized, it's less fragile. So the goal is to create a new generation of humans with enhanced intelligence and just hope that they can figure out the problems that we can't. But how on earth would this even work? You might be thinking this is pure science fiction, but proponents have laid out a technical roadmap that they argue makes this surprisingly plausible. The key here is all about the scale of the intervention. Current tech like embryo selection, it gives you a little bump, maybe a 10-point IQ boost if you're lucky. But gene editing, that's a whole different ballgame. The analysis suggests that with something like 500 edits, you could theoretically be looking at a 50-point IQ gain, a massive leap. Okay, but there's a huge catch. You can't just go into an embryo and make hundreds of precise edits. It's not possible. The only realistic way to do this is to edit stem cells first. But historically, the moment you do that, those edited stem cells lose their magic. They can no longer develop into a complete organism. That's been the roadblock for years. But a recent breakthrough called SuperSox might have just changed everything. The method is pretty incredible. You take adult skin cells, make all your edits there, and then use this SuperSox factor to rewind them back to a pristine embryonic state. Then you inject those edited cells into a donor embryo. The edited cells become the fetus, and the donor embryo just forms the placenta. It's a clever workaround. And here's the number that has proponents so excited. In mouse studies, this SuperSox method resulted in an 800% increase in the survival rate of mice born from these edited stem cells. For supporters of the idea, this isn't just an incremental step. It's the potential game changer that makes the whole concept seem feasible. Okay, so that's the how. The science is fascinating and maybe even plausible. But the real heart of the LessWrong debate isn't about the tech. It's about strategy. Is this the right move for the AI safety community to be focusing on right now? And this is where the intellectual gloves really come off. And really, the entire strategic debate just boils down to one thing: timelines. Proponents see this as a critical backup plan for a world where AGI is delayed, arguing we desperately need smarter people to solve alignment. But critics, like the commenter Noosphere89, think powerful AGI is coming fast, maybe 5 to 20 years. And if that's true, by the time any superbabies are old enough to even read a textbook, the game is already over. They argue it's a dangerous distraction from the urgent work we need to be doing today. This quote from Noosphere89 really just hits the nail on the head for the case against. It's a strategic bet, and given the plausible timelines, betting on a multi-decade biological project instead of immediate software and policy work, well, to critics, that just looks like a strategically doomed gamble. And beyond the grand strategy, the science itself is far from a done deal. Commenters were quick to poke holes in the technical assumptions. Will the effects of hundreds of gene edits actually stack up nicely, or will they cause some kind of catastrophic biological cascade? And is the underlying genetic data even reliable to begin with? It means the scientific ground here is still pretty shaky. But honestly, all of that, the timelines, the technical debates, it might all be secondary. Because the most profound, and frankly, the most chilling critique is this. What if this solution doesn't solve the alignment problem at all? What if it just creates a new and maybe even harder version of it? This comment from Ebenezer Dukakis just perfectly captures the fear. For an audience obsessed with AI alignment, this parallel is impossible to ignore. He's saying that boosting intelligence, that's the capabilities part, that's the easy bit. But aligning these new, more capable humans, that's the hard part, and it feels like it's being dangerously overlooked. And this leads directly to what's been called the second species argument. If we, Homo sapiens, create Homo super sapiens, how are they going to see us? Will they see us as their equals, or will they see us the way we see other animals? The fear is that we would be repeating our own species' grim history, only this time we'd be on the receiving end. As that same commenter pointed out, the intelligence gap between humans and apes sealed the fate of the apes, and creating a new smarter human species is playing with that exact same fire. So this brings us to the concept of human misalignment. And here's the terrifying part. Unlike AGI, which might have a totally alien mind, we know exactly what human misalignment looks like. Our own history is filled with evidence that intelligence does not correlate with morality. So the risk isn't just creating misaligned beings. It's creating smarter, more capable, more effective versions of humanity's absolute worst impulses. So where does all this leave us? Well, the debate on LessWrong is far from over. What's become clear is that there's no easy answer here. What has emerged is a fundamental, stark choice about the future of AI safety strategy, and maybe the future of humanity itself. When you boil it all down, the community is facing a strategic fork in the road. We can stick to our current path, focusing everything on AGI alignment, risking AGI omnicide, but hoping for a digital god that solves everything. Or we can pursue this biological alternative, trading that risk for a new kind of human-on-human existential risk, all for the chance that our smarter children might save us. Ultimately, this whole debate forces us to confront a really uncomfortable question. Is the AI alignment problem a technical challenge that we just haven't figured out yet? Or is the real bottleneck biological? Is it just a fundamental limitation of the minds we currently have? Which leaves us with one final provocative question to chew on. We spend all our time and energy trying to figure out how to build aligned AI, but what if the ultimate backup plan is to first figure out how to build aligned humans?